So this is my final project presentation for computer graphics, which is basically rendering isosurfaces like metaballs using marching cube algorithm. So before we talk about this project, let me just go through what is an isosurface. Isosurface is basically a 3D representation of a function which takes xyz, basically a 3D space, and converts into a particular value. These kinds of surfaces or geometries are more important in the field of CFD, geophysical data, medical imaging. And to render this kind of geometry, we actually have an algorithm called marching cubes, which is basically dividing that 3D space that function takes into smaller cubes and basically rendering based on the intersection of that particular geometry based on that functional value, and looking up in a pre-calculated table to what kind of geometry we want to render. So let me just go into rendering my project, and basically you can see these three metaballs being generated and interacting with each other, and your marching cube algorithm is basically trying to render geometry which is not very polygonal in nature. So that's why marching cube algorithm helps you render these slightly less polygonal geometry, and you can see them in different combinations. So I actually generate random metaballs with random speeds so that you get something new every time. You can also see on the left side the frame rate is slightly on the lower side, so you can actually increase the frame rate by increasing that small cube representation, and now you can see the metaball and the rendering is smooth. We also have a skybox implemented, which is being reflected back by the metaballs. And just one more point, with point 2 you can see slightly more polygonal artifacts in these metaballs. So this is what I had. Two technical things that were very important to this project and challenging was looking into this particular table in an effective manner, which involved some bitwise operation to make it effective, and figuring out the geometry based on the combination of intersection. The second was figuring out how to do the reflection vector and still have some metallic effect, and this basically required mixing two kinds of frag colors for using a mix function. Finally, you can actually have further improvement by transferring all the calculation to GPU or using different techniques like surface net or tetrahedron march. Thank you. This is what I had.